So what we do is we increase in our ALT chamber by 20 degrees Celsius. That increases the aging by four times. So essentially 1 day in ALT chamber is 4 day in calendar year. And we look at whether the implants still are intact, including the threads and
operation and all of that.
It obviously is not an exact same environment as the brain, because brain has mechanical, other more biological goops that attack at it. But it is a good testing environment for at least the enclosure and the strength of the enclosure. And I mean, we've had implants, the current version of the implant that has been in there for, close to 2.5 years, which is equivalent to a decade, and they seem to be fine.
So it's interesting that so basically close approximation is warm salt water. Hot salt water is a good testing environment.
Yeah.
By the way, I'm drinking Element, which is basically salt water, which is making me kind of. It doesn't have computational power the way the brain does, but maybe in terms of other characteristics, it's quite similar. Yeah. And I'm consuming it.
Yeah, you have to get it in the right pH too.
And then consciousness will emerge.
Yeah.
No. All right.
But by the way, the other thing that also is interesting about our enclosure is, if you look at our implant, it's not your common-looking medical implant that usually is encased in a titanium can that's laser welded. We use this polymer called PCTFE, polychlorotrifluoroethylene, which is actually commonly used in blister packs. So when you have a pill and you're trying to pop the pill, there's like kind of that plastic membrane. That's what this is. No one's actually ever used this except us. And the reason we wanted to do this is because it's electromagnetically transparent. So when we talked about the electromagnetic inductive charging with titanium can, usually if you want to do something like that, you have to have a sapphire window, and it's a very, very tough process to scale.
So you're doing a lot of iteration here on every aspect of this: the materials, the software, the hardware, all
the whole shebang.
So you mentioned scaling. Is it possible to have multiple Neuralink devices as one of the ways of scaling? To have multiple Neuralink devices implanted?
That's the goal. Yeah, we've had. Our monkeys have had 2 Neuralinks, one in each hemisphere, and then we're also looking at potential of having one in motor cortex, one in visual cortex, and one in wherever other cortex.
So focusing on a particular function, one Neuralink device.
Correct.
I wonder if there's some level of customization that can be done on the compute side. So for the motor cortex,
absolutely. That's the goal. And we talk about at Neuralink building a generalized neural interface to the brain. And that also is strategically how we're approaching this with marketing, and also with regulatory, which is, hey, look, we have the robot, and the robot can access any part of the cortex. Right now, we're focused on motor cortex with current version of the N1 that's specialized for motor decoding tasks. But also at the end of the day, there's kind of a general compute available there. But typically, if you want to really get down to kind of hyper optimizing for power and efficiency, you do need to get to some specialized function, right? But what we're saying is that, hey, you are now used to this robotic insertion techniques, which took many years of showing data and conversation with the FDA, and also internally convincing ourselves that this is safe. And now the difference is that if we go to other parts of the brain, like visual cortex, which we're interested in as our second product, obviously it's a completely different environment. The cortex is laid out very, very differently.